I believe that this is a really important part of our class now, so I don't really know or care if you like Cookie Clicker or not, but I'm going to make you like Cookie Clicker by the end of this term. We've gotten pretty far now. We've got time machines. Brings cookies from the past before they were even eaten. The next thing, I forget what the next thing is, and I definitely don't remember what the thing after that is, but like, we got portals here, opens a door to the Cookieverse, Alchemy Lab turns gold into cookies, shipments, this is bringing them in, bringing in fresh cookies from the cookie planet. Wizard Towers summons cookies with magic spells. Temples are full of precious ancient chocolate. Banks generates cookies from interest. Factories produces large quantities of cookies. We're mining cookie dough and chocolate chips. Grows cookie plants from cookie seeds. Grandma's a nice grandma to bake more cookies, and cursors are auto clicks every 10 seconds. Okay, so we're making it pretty far in this game. We've got 8 sugar lumps here, and I could start to do some upgrades here. So I think I might start upgrading. I'm gonna start upgrading this. If we get to, yeah, we've got a grimoire now, so we can start to like have spells and stuff that are going to start happening. Golden cookie. So I'm gonna pick, gosh. I'm gonna pick this one. Summon half an hour worth of your cookies per second, capped at 15% of your cookies owned. We've got 4 billion cookies there. Awesome. Okay. Today, what we're actually going to do is I want to spend a little bit of time reviewing this idea of MVC with us. So I want to step through this diagram that we started drawing last class, and then I want to mark it up a little bit more, because there were some pieces that were missing that I wanted to include in the diagram that we're going to be moving forward with, to give you a mental model of like abstract idea. Where do each of these different pieces go in terms of the architecture that we're using this term? Then what I want to do is I want to start doing some TypeScript stuff. In today's class, my goal is really to give you a taste of how your development experience is going to look. So I want to spend a little bit of time implementing a simple domain model. So this is something that is going to be really small. And I want to show a little bit about how we're going to interact with the web browser. So less how our code interacts with the web browser, maybe a little bit of that, but a lot more like, what does our web browser look like in terms of us actually using the code that we've got here? How do we use the console? How do we see output that's not necessarily showing up in the web page? How do we do things like use the debugger in our web browser so that we can start to step through the code that we're working with here? Because our environment and the actual running server are a little bit detached from each other, in that we've got this thing that's running in the background, and our web browser is the way that we're actually starting to interact with the code that we're writing. So today, what I want you to be able to do, this is continuing stuff, so I'm not going to step through this each one at a time here in terms of revealing them one at a time, but continuing, I want you to be able to apply a simple software architecture. So again, at this point, I want you to be able to describe the high-level ideas. So where do each of these things go abstractly in terms of the code that we're writing? Again, abstractly. And for you to be able to do things like describe the architecture structure. How do each of these things interact with each other in an abstract way? How do the model and the view interact with each other in an abstract way? So be able to describe those things so that you can get to the point of being able to apply it later. And continuing, maybe, implement simple graphical interfaces. I'm marking this as a maybe. We're going to do TypeScript stuff today, but we may not do like actual HTML interaction with the model that we're building today. So the maybe part is maybe we'll get to some basic interaction with HTML. But again, the goal is to give us a sense of what TypeScript development looks like in terms of the environment that we've got for ourselves this term. The first thing I want to do is reflect on these ideas of coupling and cohesion. So to remind you here, coupling and cohesion, these are measures of interrelatedness between dependencies that we have. So how much does this thing depend on the implementation details of some other thing? This is that idea of coupling. And cohesion is how well do each of these pieces fit together in whatever unit it is that we're thinking about. So whether that unit is a method or a class or an entire package of stuff, how well do each of the things that we have in this unit fit together? I want to ask you some questions about coupling and cohesion. And then I want to ask you some questions about JavaScript to make sure I have a sense of where you're at with JavaScript. I want to preface, before I even go to this, I want to preface this with the questions I'm asking you about coupling and cohesion here, the examples I'm giving you are intentionally vague. They are intentionally abstract. These are not the kind of questions I would ask you about on a test. I would not ask you about these questions like this on a test. I want to give you an opportunity to think about this in an abstract way without being encumbered with code. I would not ask you questions like this in the real world. I just want us to be able to think about it a little bit differently than we were already thinking about it. So I'm going to pop over here to my Mentimeter. And the thing I want you to measure coupling and cohesion for is this key and lock. I want you to be able to kind of think about this abstractly. And I want you to measure coupling and cohesion for this abstract idea. So interpret it as you will and measure coupling and cohesion for this thing. I'll give you like 10 seconds to do this, but you're also welcome to just talk to the person beside you if you want to have some ideas to bounce off of each other. Okay, I'll give you 10 more seconds. All right. Okay, so of the 37 people that responded here, the measurement that we've got here is that this is pretty tightly coupled and this is highly cohesive. In terms of key and lock, yeah, I 100% agree with you. This is super cohesive. These both have the idea of like securing something. I don't know, like making sure that somebody can't get into something. The lock itself isn't like trying to provide some form of entertainment, unless you want to think about lock picking as a fun activity to do. I don't know. Its primary goal is really just secure this thing. So between the lock and the key, I 100% agree that, yeah, this is super, super highly cohesive. In terms of coupling, in terms of that lock and that key, I super agree with you also. This is extremely tightly coupled. The purpose of having a key and a lock is literally so that only one key can unlock the lock. We don't want any key to unlock the lock. That wouldn't be super secure. We want that specific key to be able to unlock the lock. I'm going to give you an alternative thing to think about here. The lock itself, in terms of this like U shape, I'm going to say that that's a pretty loosely coupled thing. So just some alternative way to think about this. I can put that lock on anything that's got an appropriately sized hole to hook it into so that I can close it. It doesn't matter what door or laptop or table or whatever I'm trying to lock it to. I can use this lock in lots and lots and lots of different places. But in terms of this diagram right here, the key and the lock itself, they are super tightly coupled together, and that's very intentional. They want to be low coupling in this case between key and lock would be a very bad thing to have in terms of security. Yeah.
Like in terms of separation of stuff, when they are kind of they have different purposes, and here we're saying that they are highly cohesive. What I was thinking is that like keys are usually kept separate, like in a keychain, and then you have your lock. So I would think that it's better to have them kind of separated because they have low cohesion.
I guess I see your perspective. Having the keys separated, normally you'd bundle lots of different keys together, and then the lock itself would be separated somewhere else, where in this diagram they're attached to each other. I'm still going to say that in the context of the purpose of this whole unit is to lock something and secure it, I'm going to say that it is highly cohesive. If I gave you a keychain with lots of keys, then I'd say that's probably also pretty cohesive in that it's going to be a bundle of keys where they're all responsible for unlocking some kind of lock. Yeah. Does that sort of answer your question? Yeah. Okay, awesome. Okay, here's our next idea here. want you to think about coupling and cohesion for this idea of the train and the tracks. You're welcome to talk to each other. I'll give you about 30 seconds to answer this question, and then we'll get back together to talk about it. Okay, I'll give you about 10 more seconds to answer. All right. Okay, all right, okay. So we got high cohesion. We've got high cohesion, and we're kind of leaning more toward this is a loosely coupled thing. I'm going to agree with you on high cohesion. I think that at least in the context of this picture, the idea of a train and the tracks, they're both responsible for like moving the train around. The train has to ride on the tracks to be able to go from one place to another. So both of these things sort of have similar responsibilities. So it sort of makes sense for them to be on the same, closely attached to each other. I think that you could also make an argument that this has low cohesion. If we think about it more broadly, where low cohesion is going to be interpreted as, again, this is in my head, low cohesion here is all of the cars in this train may have different products in them. Trains can carry coal, they can carry livestock, they can carry cars, they can carry all sorts of different things where it's not, I mean, other than them having this common idea of they're being pulled somewhere, it's just a bunch of random grab bag full of stuff that's unclear what the relationship is between those things. I would also say that this could have loose coupling, and I agree with you here. My interpretation of loose coupling is, while the train's wheels, they're not really tires, wheels, I guess. While the train's wheels are designed specifically for this kind of track, I've seen trucks driving around on train tracks before, and I see lots of different train engines driving around on train tracks. My understanding of trains, and this is very limited, my understanding of trains and train tracks is that when you go to Europe and other continents, the size of the train tracks are different. They're not the same. So train tracks from the US and North America wouldn't fit on European tracks. I believe that to be the case. But here, I would say that there's a loose coupling between this engine and that train track because we can just put lots of other trains on it, at least within the context of North America. And as long as a truck has the right thing on it to be able to drive on the tracks, I think that, that you could do that. Another thing that I'm going to say in terms of loose coupling in my interpretation here is that in the same way that the train cars full of random stuff are kind of low cohesion, I'd say that this is also kind of low coupling because, I mean, the train cars don't care about what's in them. You could put whatever you want in them. As long as you can fit it physically into that thing, it's just a generic box to put stuff in. And so I would imagine that to also have low coupling. Yeah.
So is there a kind of final answer low for both of them?
I'm going to say that this is, in terms of the first thing I gave you, yeah, I think you're right that it's high cohesion. The train and the track have a pretty clear relationship to each other, and it makes sense for them to be very close to each other physically. And then the low coupling, I agree. Yeah, you can just put whatever train you want on this thing. Just to be very clear, again, I'm never going to ask you a question like this on the test. This is so highly subjective, and there's so many interpretations of the image I'm giving you that I'd never ask you a question like this. Yeah.
So like highly cohesive means that two things are kind of forming a single system. They're working towards the same goal, that kind of thing.
In some ways, yes. Working toward a common goal, forming a single system. I'm going to think back specifically now to code. When I have a UI layer that does all the input and output for all the different things in my system, I would say that those are all highly cohesive if they're all in the same package. So they're not necessarily trying to do the same single task. They're all doing different inputs and outputs for different parts of our system, but they're all doing input and output for the system.
High level, like the general, the ultimate purpose of all of those things is the same, and that's why they are.
Yes, yeah. Okay, one last abstract image here. I'll give you 30 seconds here. The thing I'm thinking about in this is the webcam and potentially also the cable that attaches it to the device that it's attached to. I'll give you about 30 seconds. Feel free to talk to somebody about it.
They are, yeah.
Right click? Is the webcam on the other device or the webcam and its cable?
The webcam, the cable, and the other device that it connects to, yeah. Oh, no, I'm sorry. Again, this is so highly interpretable and highly subjective, yeah. Okay, I'll give you about 10 more seconds to respond. All right. Okay. So we're kind of in the middle on cohesion. Like this is actually, given that we've got 42 people responding, we're so close to the middle on cohesion here that I'm surprised. I'm really surprised to see that. I would say that this is a highly cohesive device, the webcam itself. It's got a camera in it and it's got a microphone in it. And its job is really to like support the idea of making videos. Most videos that I watch have audio in them, and supporting things like asynchronous meetings, so like interacting with people online. In that case, I'm going to say that this webcam itself is fairly highly cohesive. There are different things here, yes, but they're all toward the same common goal, to accomplish taking videos or interacting with somebody else online. I could argue that for that same reason, this is low cohesion. Recording audio isn't a necessity for recording video. It's not absolutely necessary, but I think it's more realistic for this to be highly cohesive. They are really essential for each other to kind of be there. I'm going to say that this has pretty low coupling, and that part I think we agree on here, that this has pretty low coupling. In terms of like the cable and the device it attached to, so sorry if I didn't clarify that, but in terms of this thing, the cable and the device that it attaches to, it's a USB device. When I plug this into my laptop or your laptop or my desktop PC or whatever, as long as it's got a USB port and it's able to support webcams, it actually doesn't even matter what the webcam is. I know we've all got webcams in our laptops, but for those of you that have desktop PCs at home and a webcam that you've plugged into it, when was the last time you installed extra software to support the video on the device? You might have other software for that, but when was the last time you actually installed something? Did anybody install anything else to drive the video on a webcam they plugged in? Good. Nobody has done that. Awesome. Most operating systems, Linux, Windows, Mac OS, they just work. And if we think back to last class, there was a question about standards. Do standardization kind of help with this idea of low coupling? I think that was you. Yeah. In this case, video devices, that's a standard. That's a pretty common standard across operating systems. Hardware vendors all stick to the same standard so that when you plug it in, it just works. This takes me to another point, which is outside the context of this image, but I want to dwell on it for just a moment. This is not universally true of devices that you can plug in with USB. When you plug in, gosh, what do people even plug into their computers anymore? What else would we plug in? When you plug in a drawing tablet, okay, how many people have like Bamboo or Wacom tablets for drawing? About four or five of you. You do need a driver for that. You have to actually install extra software for that. The word I want to focus on here is driver. You can stop listening if you don't care about this. This is not part of the course. Driver. A driver is a piece of software that is used in an operating system to support specific devices or specific kinds of devices. When you plug in your Wacom tablet or your Bamboo is Wacom, I think, I don't know. When you plug it into your machine, it shows up as possibly unknown device. I don't know what this thing is. You have to install this extra software to support it. That driver knows all about how that hardware device works. It must know all about how that hardware device works so that it can actually do stuff in your system. So that when you open Photoshop or Krita or whatever drawing software you're using, it can see that there's this device there and it can get the input from it. So drivers, when we plug in hardware devices and our machine picks it up and it says, hey, I know what this is, some drivers are written to standards and some hardware vendors will implement standards. Some drivers are written for very specific devices and they only work for that very specific device. And so for that case, I'm going to say that there's tight coupling there with a driver and a specific device. Webcams, again, don't really fit into that criteria. There are standards for video. All operating systems implement those standards. Hardware vendors all implement those standards. So there is loose coupling there between those things. There's some coupling, but there's loose coupling between those things. All right. Are there any questions before we move on to the next set of questions? Yeah.
Between the webcam and the device itself, there is kind of loose coupling, but you can connect it to any other, like any other webcam can be connected to that device. And there is low cohesion because like the device that we're working with, the computer, for example, has kind of a different purpose than video and audio. That is not its main kind of priority.
I guess in this case, I'd say there's some kind of mid-level cohesion then. You are using that computer to record the video. Otherwise, why would you plug in the webcam in the first place? If you think about that as a whole unit, then I guess I would say that this has middling cohesion because of the other part of what you said. It does all sorts of other stuff. It's a general purpose device. It's not just for recording video and doing nothing else as a whole unit, yeah. All right, okay. Yeah, let's do this. One last one. I'll give you 10 seconds to think about this. And then I'll give you 10 more seconds to respond. Of course, you're welcome to talk to each other if you want. Okay, 5 seconds. All right, okay. This is a really vague image. This is a really, really vague image. I'm going to agree with you and say that this has super high cohesion. It's just a bunch of Lego, and all Lego is Lego. I don't know about any of you, but when I was a kid, I had a big bucket full of Lego, and we currently have 2 big buckets full of Lego in my house, one for each kid. I'm going to say that I agree with you that this is kind of middle coupling. The reason that I'm going to say that this is middle coupling is that, maybe not for what you're thinking about, but each of these kind of just plugs into whatever other Lego piece you want, as long as it's got, I believe that these little circles are called pips. I believe they're called pips. But I might be thinking of dice. Are they called pips? You're nodding like, okay. Yes, they are called pips. Okay, you can just plop them onto whatever other thing has pips. But the other thing that you may or may not know is that you can also put Duplo blocks on these things. This is a big reveal and our minds are blown, I know. You can fit Duplo blocks. Duplo blocks are for like little kids. They're the really big blocks and they have the really big pips that kind of connect to each other. The spacing on the pips that we have on Lego pieces like this are such that the Duplo pieces are also correctly sized so you can put Duplo pieces on top of Lego pieces. Not the reverse. The pips are too big on the Duplo pieces, but you can put Duplo pieces on top of Lego pieces. All right, so now I want to ask you some kind of pre-assessment questions about JavaScript. This is not code that I expect you to do anything with, so you don't have to worry about reading it. I just copied this from Wikipedia on JavaScript. Although I did read an article the other day on this idea of temporal versus the date class in JavaScript. If you want to go on a wild ride, I invite you to figure out how to use the date class in JavaScript in terms of parsing strings that represent dates. I'll try to find that article and post it on the course discussion forum. So I got 3 questions for you here about JavaScript so that I can have a sense of where you're at with JavaScript. I have already talked to John Braco about where you're at with JavaScript, but I want to get a sense of where you're at with JavaScript anyway. Here's our first question. Okay, awesome. So yeah, using that number sign prefix on instance variables marks it as truly private. You cannot use it from other places. Using the private keyword, that's actually something that's added with TypeScript. In terms of JavaScript, the number sign prefix is the way that you can add privacy for variables. Here's our next question. Okay, all right. I am really happy to see that it's in the middle here. It is easier. I'm not going to disagree with this point, so I'll give a little bit of spiritual credit to this. It certainly is easier to just say equals and just like get the property. It is absolutely easier. It's at least 2 keystrokes easier every time you want to type this stuff out to get something or to set something. It's the default design by JS designers. I'd argue that the same thing could be said about Java, and I wouldn't leave all of my instance variables public in a Java class. I would want to hide all of those implementation details. This part, you can use the get and set keywords later. This is something that is true for both JavaScript and Python, actually. With Python, you can effectively override properties by using special keywords and functions on a class to be able to say that when you access or modify this value, you should use this method instead. The idea that you can override the assignment operator with the set keywords and the accessor, so like getting access to a property using that get keywords, that's pretty powerful because it means that you can just put those references as property names in the code, and you don't have to change it if you want to actually add behavior to the accessor or if you want to add behavior to the mutator later. So leaving them public to begin with is a reasonable design choice. It's a reasonable design choice in the context of JavaScript. Here's our very last question. Wonderful. Yes, it is the constructor keyword. This is something that in my fingers I always get caught up on because I'm always just typing the name of the class in as the thing I want. One thing that I did learn about JavaScript very recently is that you cannot make a private constructor. It's forbidden. You can't make a private constructor in JavaScript. The way that you make your constructor private in JavaScript is to have a public constructor that uses a static variable or just like throws an exception. You can't call this thing. You're not allowed to call this method. And so it's a runtime thing as opposed to a compile time thing. Snuggles. All right, congrats to Montana, whoever you happen to be. And thank you all for putting up with my abstract nonsense of coupling and cohesion. All right, so what I would like to do right now is to take a look back at the diagram that we started working on last class, to review what it is and to spend a tiny bit more time annotating what we've got there. After today's class, I'll publish this this diagram up on the course webpage for you. I'm going to have to start up my screen sharing thing. Okay. So MVC, Model View Controller, consists of 3 major parts as an architecture. We've got this group of things that are going to be called the controllers for our system. We've got the model itself, and we've got the views for our system and for our domain model objects. In terms of how these are all going to be represented in code for us this term, our TypeScript, our controller, these are going to be purely TypeScript code. The responsibility of a controller in this MVC architecture is to effectively receive input from the person sitting at the machine. I'm going to abstract that person away, and I'm going to say that this is really just going to be receiving things like button clicks. It's receiving events. It's receiving these events in TypeScript, and it's going to have the responsibility of coordinating which methods and which objects are going to be either interacted with as a result of that interaction. I click the button and something is going to get updated. Some existing domain model is going to be updated, or some new domain model instance will be created as a result of this. The controller's job is really about making decisions about, given this input, what am I going to do? What am I supposed to do? How do I ask the model to change? The model is going to be, in terms of thinking about our tiered multi-layer architecture, our model is going to be representing the domain model, so the class instances that we've got. It's going to be representing the logic of the application. When we start doing this, this is also going to have the responsibility of doing persistence. Not directly. I don't want to write SQL statements in my domain model classes, but it's going to be responsible for asking something to do that. I'm going to make changes to myself. I'm going to be constructed, and I want to ask something else to save me. I'm a new instance. I want to be inserted into the database. I'm an existing instance. I want you to update the values that I have for me in the database. So our model in this MVC architecture has lots of responsibilities that we didn't have in our layered architecture. So we're going to represent the core ideas of our system, we're going to represent the logic of our system, and we're going to be ultimately responsible for interacting with the persistence thing that we're doing for these classes. The domain model is purely TypeScript. This is purely code. We don't really want it to have any responsibility for doing things like presenting itself. It's the same as what we had before in Comp 2450 with our layered architecture. Our domain model shouldn't be responsible for presenting itself. Here, we don't want our model to have that same responsibility of presenting itself. The separation between our model and our view, though, makes that a lot easier to accomplish than what we had with pure text-based output. In the system that we're going to start working with here, you can console.log as much as you want. My mom is never going to see what you print out with console.log. She's never going to open up the console to be able to see what you've written out with console.log. The separation that we have between model and view is that our view is going to be purely responsible for presenting the state of these model objects. It's just presentation. It's just about showing the values that we have here. And so this is ultimately this UI layer that we had. This is going to be a combination of TypeScript and HTML. HTML is really the presentation tool that we're using. And TypeScript is going to be here because our model will be notifying the view of changes, And kind of in the opposite way here, I'm going to draw an arrow back up to here. We're going to have that our view is responsible for listening for changes. Our view is responsible for effectively binding itself. I'm going to use the word binding. Do we all sort of have a vague idea of what the word binding means? Sorta, kind of, sorta. Yes, no, please. Okay, thumbs down. Okay, thumbs down. When I'm saying the word binding here, I'm effectively meaning they're binding themselves together. They're joining in some way. They're going to be connected in some way. They're going to have some relationship to each other. Our TypeScript code for the view is ultimately going to have some responsibility to say, hey, model, I'm interested in knowing when you change. I want to know when you change so that I can change the underlying HTML representation that I have for you. If any of the properties that you have change, please tell me so that I can then ask you what are the current values that you have so that I can update the view to present what state you're actually in right now. The view then will have some responsibility to interact with the controllers in the form of there are buttons that are on the view, and we're going to make those buttons such that they have those on-click listeners. When I click on a button, it's going to call a method on my controller object so that it can start actually interacting with the model, and they're kind of like feeding back on each other this way. In some circumstances, we may also have the responsibility in our controller for doing listening here. But it's some limited circumstances. We may never need to do this in this class, but it's also reasonable for the controller to be listening to the domain model instances to determine when they have changed with each other. The very last thing that our controller is possibly going to be responsible for is creating instances of the view. So it will have the responsibility of, hey, this button just got clicked. I'm invoking this method. I'm going to ask the domain model to make changes to itself, but I may also be responsible for adding new layout to the screen. So asking for new instances of view classes to be added, new HTML to be added to the screen. But it's going to ask these view classes to do that. It may also have the responsibility of binding these view classes. So making sure that these things are connected to each other in some way, invoking methods on both of them and passing them around to each other so that they know about each other. This is a high-level abstract representation of what we're doing. We'll get into code today and on Tuesday next week and going forward in the course. But I want to give you, again, a hazy idea of where things fit together. Does anybody have any questions about this before we proceed? Yeah.
So before seeing the actual structure of the code with this architecture, can we vaguely understand what is the reason that this kind of an architecture compared to N-tier fits better with GUIs rather than the other ones?
That's a fair question. So the question is about, ultimately it's about why is this better for graphical user interfaces than the N-tier architecture or layered architecture? I think ultimately that's what your question is. I want to start this by saying the N-tier and layered architecture is not bad for GUIs. It's not like you can't use the N-tier architecture for GUIs, and I think I demonstrated that last term. It's possible to accomplish that with GUIs. And in fact, with a lot of actual web applications, there's going to be some layers to the application. The front end may use MVC as its own thing, but the back end stuff might be a tiered or layered architecture internally. The thing that I think makes this better for graphical user interfaces is the relationship that we have between the model and the view here, where the model is effectively telling the view that it needs to update itself. With the layered architecture, we kind of have to go through this full path all the way to the back end and then back up to the front end before the UI would be able to register changes for itself. In this case, we're going to ask something to do something for us. There may or may not be changes to the UI as a result of that, but there also may or may not be changes to different parts of the UI as a result of that. When I ask this controller, I clicked this button and I've added a Pokemon to my team. There might be multiple different places in the UI that would need to be updated as a result of that. Having this listener-based architecture where we're making changes to our domain model and the view is updating itself based on those changes, that's a little bit easier to manage these far away different parts of our system that need to be updated as opposed to that end-tier architecture where going all the way to the bottom and then back up to the top again, now we kind of have to decide what are all the different places that need to change way up here after all of that stuff has been done with that end-tier architecture.
And with the other one, we can kind of decide on the way of doing the backend.
With this one here, our backend is telling us, the domain model is telling us, I've changed myself. If you're listening to me right now, then if you're listening to me, the domain model object right now, then you should also update yourself as a result of those changes.
So it's no longer kind of the presentation itself deciding what needs to be changed. It's kind of the model telling it that we have.
Yeah, so the presentation is being told that there were updates to this domain model instance. It still has to like update itself in terms of changing the value of fields that we have on the screen, but it's not making that decision to update itself by itself. It's being told that this thing has changed and it should be updated.
Also, like, what I wanted to ask is I think we're good.
Okay.
How much does the controller do to the view? When it creates an instance of it, and then after an instance is created, is it going to be like doing anything to the view afterwards in terms of updates?
Once the controller makes an instance of the view and connects the model with the view, it disengages other than receiving input from the view itself. So the only relationship after the creation is going to be that this button got clicked, and now I'm going to execute a method in my controller object. I think there was a question here. Yeah.
We have an arrow that points from model to view. It says notify changes. Does that also include telling the view to update itself?
Notifying it of changes is telling it to update itself. So underneath all of this structure, the idea that we have between a model and a view is that all of our domain model instances are going to have effectively an array of objects that are interested in knowing when it's been updated. When it updates itself, the model will then go through that list of things that are listening, and it will say, hey, I've updated myself. You should do something as a result of that. So the notify changes here is basically the view will be created. It will say, hey, model, I'm interested in listening to changes about you. Let me know when you change. It will kind of present itself. And then when the model says, hey, I've updated myself, the view will be one of those listeners and get notified of the updates. Does that answer your question? Okay, awesome. Yeah.
Describe the responsibilities of each of these parts. When describing, for example, for view or controller, we also need to state that it's responsible for listening. It's not just one direction. The model is responsible for notifying, and the view is responsible for listening.
Yeah, I would expect you to kind of have that idea that there's two sides of the responsibility. So to restate what you're saying, knowing that the model is responsible for notifying and the view is responsible for listening, that's a bidirectional relationship, and I kind of expect you to know about both sides of that relationship. Yeah.
Related to that same concept, how the model and view both tell each other and listen to each other. Would you also say that the model also has to listen to the controller for changes from the controller?
The model will not directly listen to changes from the controller. So when I'm using the word listening, I want this to be considered as like a passive ongoing thing, where the controller relationship with the view is it created that instance, the relationship is over between those things. The controller it's listening for events to happen from those view objects, but it's not the listening structure that we're thinking about with the relationship between model and view. The view will just directly invoke methods on the controller when the buttons are being clicked. There's an indirect relationship between the model and the view in that the view is passively waiting around and listening for events to happen that are told to it by the model objects themselves.
Will we just get a better understanding of the distinction guess, as we have code.
As I write code, that might make a little bit clearer kind of the idea of that I'm describing here in terms of the relationship. But the one keyword I want you to kind of focus on here is that this is an ongoing thing. Yeah, the model will have all instances of other classes in it that are listening. It's going to keep track of everybody that's interested in listening for events to happen from this. Whereas the controller, it doesn't have to maintain that state because it's just got other things that are going to call directly to it. I want you to do this thing right now. Yeah. Yeah.
Like the controller doesn't have any state. It kind of doesn't even wait for something to kind of pass some kind of notification to it that something has changed. It simply will be called by the view.
It's not going to be indirect notifications in the way that we're talking about with the model and the view. It's going to be direct notifications. I'm invoking this method on this object right now. Yeah.
Also, like, can you explain in what rare cases would we have that the controller is listening for something in the model, and when describing the responsibilities of these parts, would we really be required to state that it is listening for the model as well?
That's a good question. Ultimately, this is such a rare scenario in my head that I wouldn't be too concerned about you knowing that the controller might be also listening for stuff happening. This can possibly happen if the construction of a model instance would require the creation of even more view objects, but that's going to be in like a really special circumstance where it does sometimes and it doesn't other times. And it makes as much sense to use and abuse this listening infrastructure to be able to cause those things to happen. But I'm unlikely to ever see that actually happening in the structure that we've got. And when I do write code for these controllers for you in class, we're not even going to include that idea in our system to start. Yeah.
So just to clarify, what you mean by listening, it's more like model sends a request and then like the view changes itself. But when controller receives something, it just directly changes the model. It's not like it's requesting anything.
No. So the controller will call methods on the model objects. It's going to say set, or it's going to call some other method. The model, when it's notifying these other views, it's going to go through a list of all the active listeners and say, hey, I've updated, hey, I've updated, hey, I've updated. But the controller relationship with view, with model is directly create instances, call the constructor, or call like accessors, mutators, or other methods that are on those objects.
Kind of like between the view and the model, there is kind of an open path that stays open all the time, kind of like a socket between them.
Kind of, sort of, except it's not really a socket. It's that one has references to the other object. So our domain model instances will have references to the corresponding view object. But it doesn't know or care that they're views. It's just something that's interested in listening for notifications to be sent to it. Yeah. I will publish this one after class today, yeah. I didn't want to publish it yesterday or last class because it was still sort of incomplete, but as far as I'm concerned now it's complete, and I'll put it up in today's lecture notes section. Okay, again, hazy idea. I hope that we have a hazy idea of kind of how these parts interact with each other, and I hope to solidify that a little bit more as we proceed with implementation. I want to go back to my slides very briefly here. And what I want to do today is I want to start actually taking a look at doing TypeScript development as a language in the browser. Your experience with JavaScript from Comp 2400, based on what I saw here, you got a pretty good idea how JavaScript works, but your environment was Node and CodeGrade, I guess. But kind of like the terminal is how I would expect you to use JavaScript from that. And so we're going to spend a little bit of time today thinking about the environment that we're using, which is the web browser. And I want to start introducing some of the ideas of TypeScript to you for this. So what I want to do today is I want to write a class. The class that I have here, I want to make sure that we're going to do things like encapsulation, kind of remind you of that get set keyword and the idea of privacy. So I think you have a good idea of what that looks like. I want to do output here from the context of, I want you to see where output goes in the browser tools. I want you to see and be able to start using the development tools that's built into your web browser to be able to start interacting with the objects that you have floating around in your system. The other thing I want to introduce to you is this idea of types with TypeScript. So how do we actually do things like declare variables such that they have an actual type associated with them? And what kinds of things does the type system give us, at least for free from the beginning? Then, kind of in combination with this, I want to spend a little bit of time thinking about the physical and logical organization of code. There are no packages in TypeScript in the same way that there are packages in Java, but I want us to kind of simulate that package structure that we had with Java. So the way that we're going to do that is using modules and files. And then time permitted, we'll start doing some MVC related implementation stuff, but more likely that's going to start happening next week in class. Where I want to start with you is I want you to be able to see the domain model class that I want to implement here. This is that minimal Pokemon class that I described to you last week in terms of minimum viable product for domain models. We've got a Pokemon instance class here. It has a single property, which is the hit points that it has. We have a class invariant, and the only class invariant that we have for this is that HP must be 0 or higher, and we've got two methods on this: attack some other Pokemon or to change health for that specific Pokemon. I'm not going to leave this up here while we're doing the coding exercise because it's pretty constrained. There's not a lot of stuff going on here. If you want to play along with me today and follow along with the code that I'm writing, what I am going to be starting from is that basic Vite structure that we had at the closer to the beginning of the term when we were starting to write code. If you want to follow along with me in class in general, I am going to push up to GitLab the stuff that I have after class today. But if you just want to kind of like follow along on your own, have another Vite project for class examples and have one for your actual project for the course. Yeah.
So could this domain model object be simplified even more for the purpose of making a viable product? As in, we could have entirely removed the change health method, because when we're calling attack and having another Pokemon, we have access to its state directly. Is it the case that, as in Java, we have direct access to the state of another instance of Pokemon?
To your question, do we have access to private members within the same class? Yes, we do have direct access to that. So because we're accepting some other Pokemon, we could reduce its health by some amount as a result of the attack.
We could have had just one method in this case.
We could have had just one method in this case, yes, but I'm just gonna do it this way. I'm gonna do it this way, yeah.
I also think about in terms of cohesion. Like this kind of aligns with that idea compared to having them together, or having them together is also kind of fun because it's doing the same thing within that unit doesn't matter.
I'm going to make the argument, and this is now me going beyond the MVP, having a change health method makes sense because I would eventually want to be able to restore health of the Pokemon that I've got eventually. I'm violating my own rules here, but I think it's reasonable to have a change health method to kind of focus that specific idea of changing the value of its health. And separating it from the idea of attacking.
Separating, like if we had them together, that would be kind of low cohesion in kind of some kind of a sense.
I would call that a little bit lower cohesion, yes. Yeah. Okay. So I'm going to pop over to my terminal here. And this is the project that I started last week that with Vite. The first thing that I'm going to do here is I want to start my server again so that I can start interacting with this in my web browser. I would invite you to open another tab or to open up a terminal in LazyVim if you're using LazyVim or in whatever tool you're using. I'm going to open up a new terminal here at the bottom of my screen. And I'm just going to have a little terminal here at the bottom that's going to be responsible for running my web server. I'm going to go to the project that we've got in this directory. So this directory that I'm looking at right now, this is the folder that has my project in it. If you've already done npm create Vite at latest. This is what your folder structure is going to look like right now. When you do npm create Vite at latest, it will auto start the server for you. But when we stop it, we'll need to be able to start it again. And there's two ways that you can do that. One is to say npm run dev. This will start the web server in this module. The other way that you can do it is to use npx. npx is a tool that will kind of look in the current directory for a node modules directory to find programs in it. And the program name that we want to run here is Vite. So when I run npx Vite, it will start my web server here. And I've got that URL that I can paste into my web browser or click on to get access to that. So I'm going to copy this. I'm going to pop over to my web browser here. I'm going to open a new terminal. I'm going to paste it. And our web server here is running right now. I'm going to go back to my project. And I'm going to start making some changes to code here. Main is what I'm going to recommend that you use as the name for the file that is the entry point for your project. So this is where I'm going to start doing coding for this thing. I'm going to move stuff later, but for now I just want to start here because this is the file that is directly being referenced by the index.html file. So this is the one that's actually being loaded by index.html when we're starting this. For this, I'm actually going to go to the top here, and I'm just going to delete everything. I'm going to say DG.
So could you move to the index.html?
Yeah.
So this absolute path for that main TypeScript file. So it is related to the structure of this project itself within the computer, but you also mentioned that it is related to the address of the local host. In what kind of a sense are those two related to each other?
It's related to the address of localhost in that if I go to / source main.ts, I would expect it to load there, but I think that there's some other magic going on behind it. Oh, there's nothing showing up because I deleted it. It's empty, yeah. Why is there nothing showing up in this file? Because I literally just deleted everything and it's empty. So it's showing up as this part, and I realize that's very small. Sorry for people at the back, but I've got / src / main.ts. That's the relationship between.
That would show the TypeScript code.
Yeah, yeah. So this is also showing nothing now because there is no interaction here. I'm not actually making anything, and index.html is effectively a blank thing. So I'm going to pop back over here to main.ts, and what I want to start doing is making a class. The syntax for this is really similar to what you would have seen in Comp 2400 with JavaScript. So feel free to type along with me if you want to follow along. I'm implementing this same class that I showed you just a moment ago. So I'm going to start here by saying class Pokemon. And the one thing that I want to have in this is a private variable that's called HP. The new difference compared to what you were doing with JavaScript before is now you have to specify the type of this thing that you want to have here. In TypeScript, the type name and the name of the variable or method or whatever that you're using is inverted from Java. So we specify the type name first, we put a colon here, and then we specify the type. We specify the name, colon, and then the type of the value that we want to have here. So for me, I want to have this private value HP be a number. This is something that I want to use as a number. Number in JavaScript, it is the numeric type. It's floating point numbers. Yes, I know. We're going to ignore that fact for now. But it can be regular integers. So we're going to use regular integers when we're interacting with this. I need to have a constructor for this thing. So I'm going to add a new constructor. And what I'm going to say for this constructor is that I want to take an argument as input to be the initial HP of this Pokemon. And I have to specify the type of this thing. I explicitly want to accept numbers here. I don't want to accept any other kind of thing. In JavaScript, we then have to check, is this actually a number that's been passed to me? In TypeScript, this is going to be enforced by the compiler. This is something that's happening at compile time, so I don't really have to do those special checks. The other thing I don't have to check here is whether or not this is null, because the type system forces us to not be allowed to type null as a hard-coded value into this. If I wanted to allow anything like number and also null here, I would have to say null is an acceptable value for this. I don't want null to be an acceptable value, so I'm going to remove that. Yeah.
So if it's implicit here that null is not acceptable, so why in that initial, like the initial main TypeScript file we had, in the comments there, we put the exclamation mark to explicitly state that it should be.
The exclamation point, why did we have that exclamation point in the initial one? The exclamation point was put there because we were starting to interact with JavaScript stuff. When we were interacting with JavaScript stuff, we, actually have no idea what it's going to return. TypeScript as a compiler doesn't really look at the JavaScript code that it's interacting with. But the other thing is that the method that we were calling document.querySelector, it can return undefined or null. That type assertion, the exclamation point there says, me, as the dev, I'm promising that I know that this is not going to be null, so please don't give me compile errors after this saying that the value could possibly be null. I'm asserting that this is a non-null value. It will still crash at runtime if it does return null. It's still going to fail at runtime, but the compiler will not forbid us from proceeding after that point. Okay. So I've got this constructor. I'm going to say this dot. So the same sort of syntax as we've seen before. And I'm going to add some accessors, and I'm going to add an accessor to this. So get HP. This returns a number. Got the two other methods that I want to invoke here, or create. The first one is the change health method. And what I want to accept here is by, and this is a number. So this is how much I'm going to reduce or add to this. And I'm going to say for us, for now, that this is also going to return a number. The number that we're going to return here is the current health. So after the change has been made, what's the resulting value of the health? I've got a class invariant that says that this value must not be less than 0. So I want to make sure that that's going to be enforced. So I'm going to say if by plus this dot HP is less than 0, is greater than 0, sorry, then I'll say this dot HP plus equals by. And then I'm going to return at the end this dot HP. This is the value of the HP after that's been done.
I don't think we did do anything for the constructor, like to make sure the health is well.
That's fair. And I'm actually going to just leave that for now because I want to come back to this in just a second. The last thing I want to do is add an attack method. This is going to take as input some other Pokemon, and the type of that thing is also going to be Pokemon. So inverted structure here, name of the variable and then the type coming after it. Here, I'm also going to say that this returns void. This doesn't return anything. When I'm returning void, I do not have to put :void after that. I can, you are able to do that, but I'm not required to do that. It's just implied to be a void return method if it doesn't have a return statement that includes a value or if it doesn't specify this. So here's what I'm going to say, other dot change health. And I'll start by saying -1 here. But I'm going to recognize that I want to change this just a little bit to use something like a static constant. So I'm going to pop back up here to the top. I'm going to add a static constant here, a static private constant to say static damage. And I'm going to say that this is equal to -1. Similar to using the var keyword or the auto keywords, the var keyword in Java or the auto keyword in C++, the type of damage here is implied by the value that we're assigning to it. So it will also have a type of number assigned to it. Then what I can say down here is change health, and then I'm going to say Pokemon dot number sign damage. I want to refer to this, this private static variable that we have for the class. Yeah.
Sorry, and just to clarify, when we don't specify the type, we declare that variable, it's just inferred.
It can be inferred. If it's not able to be inferred, your compiler will tell you, I don't know what you're trying to do. You need to specify the type. Yeah. The type inference is happening up here on the place where we're declaring this static variable. You can say damage colon number equals -1, but it's inferred here that we're assigning this value of -1 to it, so it's a number. Yeah. The last thing I want to show you here is in Java, we were doing class invariants using the preconditions library, the preconditions class from the Guava library. Java does have an assert keyword, but getting it turned on and off is awkward and painful, so we just never used it last term. TypeScript as a language does not have an assert keyword in the same way that Java has that assert keyword, but it does have some idea of assertions in general. And so the very last thing I want to do here is I want to write a method that I can use in a class invariant for this. And the method that I want to, a function that I want to write for this is just going to be a free function. It's not going to be attached to any class instance. And we'll eventually move this into its own file. But I want to say here function. So function is the keyword to start function. I'm going to make a method here that's called assert positive. And what I want to accept as input here is a number typed argument. And what I want to return from this is not a value. This is not a type of value that I want to return. But what I want to be able to say with this is I want to tell the TypeScript compiler about the value that has been passed into this thing. I'm going to use this new keyword that is assert with an S at the end. It's not assert, but it's asserts. And the thing that I'm going to put after this is I'm going to say that val, that's the name of the variable that I have here. Val is number. What this tells the TypeScript compiler is that the value that has been passed to me is indeed a number. This seems a little bit redundant, and it is a tiny bit redundant, but it's a way for us, at least in this case, to say you can assume things about the value that's been passed to me after this. We can have type assertions on things that are like any here. I will accept any value as input, and what you can assume about that value after calling this method is that it is a number type. But for us, what I want to say is that this asserts that val is number, and what we're going to do here is write our own little assertion function. I'm going to say if val is less than 0, then I want to throw new error. I'll write a tiny message in this. Otherwise, I'm just going to do nothing. I don't need to return anything here. If I was successfully able to run this function or this method, then the value itself is a number. The last part I want to add to my class here now is going to be the class invariant itself. So I want to use this assertion that I've just written. Similar to our Java classes, I'm going to say check Pokemon. There are no arguments here. It returns void. The only thing I'm going to do here is assert positive. And the thing I'm going to pass to this is this.hp. I want to call this here after I've constructed it. And I want to call it here after I've changed it. I'll zoom out here just a little bit so that we can kind of see the whole thing. Yeah.
So what's the reason we're using the asserts syntax for a function instead of just using the number type that we did mention the structure?
The asserts method that we're using here, the asserts part of the assert method that we've written, we can use this in more complex places. We can say things hypothetically, theoretically. We can accept an instance of Pokemon, and then we can define another type of valid Pokemon that is not constructible by any other means. And then we can say that after you call this method, by passing this Pokemon instance to it, we can say asserts this value is valid Pokemon. And then everything after that can assume from the compiler perspective that this is that specific type. It satisfies the requirements of that specific type. This is redundant. I'm saying that the value that was passed to me it must be a number, and I'm saying afterwards it is still a number type, but we could use it in more complex ways. I could define a type that is positive number if I wanted to and assert that, but I don't want to add that complexity right now. For me, for type assertions, for class invariant assertions, this is enough. This is enough for us to proceed. The very last thing that I want to do here, we're kind of running to the end of class. I'm going to go to the bottom of my file. And what I want to do here is I want to start making an instance of this thing and starting to interact with it in my web browser. As far as our web browser is concerned, if I go back to this page, there's still nothing here because I don't do anything and my HTML document is empty. It has that div, but there's not actually anything in it. So I'm going to create a new instance of this Pokemon. We have to pass as an input to this Pokemon some initial health. So I'll say that this one has 10 health. And then what I want to do is I'm going to say console.log my Pokemon. You are familiar with console.log. You've used this before in JavaScript, but the place where this shows up is now going to be in a different location than what you would have seen before. I'm going to pop to my web browser now. I'm going to open up the developer console. I'm going to click on this inspect. I think there's a keyboard shortcut that you can use to get this up in Chrome and Firefox. I'm going to zoom in a lot. This is going to be our dashboard for like inspecting the state of what things are right now as we proceed throughout this course. This inspector here that's looking at HTML elements, when we look at the source code of index.html, we're seeing what we've written in the file itself. When we look at this inspector, it's the current state of it after we've added elements and after we've changed text and stuff. This will be the current state of what we're looking at. The two other tabs that we're interested in here are console and debugger. If I go to console here, I can see that I've got this statement that has been logged that is saying that there's an object that has been logged that has HP of 10. If I expand this a little bit, I can also see things like this is the class that it came from. So the constructor here is from this class Pokemon. This is kind of referring ultimately to the JavaScript compiled code, which is why we have the word object showing up there instead of Pokemon in console.log itself. But it gives us the ability to ask questions about what was the state of this object when it was logged to the console here. The other thing that is important for us is the debugger tab here. In the debugger tab, I can start to do things like take a look at the code that I've got here and be able to do things like set breakpoints on different parts of it. Setting a breakpoint here is not actually very valuable, but I could set a breakpoint here in my constructor. If I refresh my page now, it's going to break on that and allow me to kind of like console.log step around and see what things are, but it will give me the ability to interrogate the state that we have of the system that we've got right now. I'm using Firefox to do this. If you're using Chrome, there are web tools that are built into it. If you're using Safari, I think there are web tools built into it that look like this. If you're using other Chromium-based web browsers, it will have something that looks a lot like this. It's not going to be identical, but the structure will overall be the same. There's going to be some kind of inspector, some kind of console, and some kind of debugger to be able to interact with your code. Continuing into next week, we'll keep working on this example and building stuff up. But at this point, you should be able to apply this software architecture in the form of telling me a little bit about the different responsibilities and the different parts of it. And you should at this point be able to at least start thinking about how you'd start building a domain model structure with the TypeScript that we've got. That's it for today. I hope you have a great weekend, and I will see you